Example 10, the minute hand on a watch is 8 millimeter long and the hour hand is 4 millimeters long. How fast is the distance between the tips of the hands changing at 1 o'clock? Let's see. What we know is that the length of the minute hand or the blue hand over here is a constant 8, and then our hand is a constant 4. We're talking about the d, the distance between the tip being changing, and the theta, the angle between them, changing. It seems like I should know how theta is changing because I know what the angular speed of minute hand and hour hand is. And so if I subtract the angular speed, here I'm subtracting the angular speed of the minute hand from hour hand, and so at 1 o'clock the minute hand is getting closer and closer to our hand, and so I have to have a negative value in there, and then the angular speed of the hour hand is basically a full rotation, 2 pi divided by 12 times 60, that's the number of minutes in a day, in 12 hours, and then the angular speed of the minute hand is the full rotation divided by 60 minutes, and that gives me the rotation that that gives me the rate of change of theta. And then why do I need that? I need to relate d and theta somehow, and again d, 4, and 8 are 3 sides of a triangle, and what I know is the cosine, law of cosine. So d squared is equal to m squared, which is 8 to power 2, and plus h squared, which is 4 to power 2, minus 2 times m times h times cosine theta, m and h being 8 and 4. And so a bunch of constants, and there's a cosine theta and d squared. And then so let's watch how the two hands are getting closer and closer to each other, and that's what is happening. But another interesting fact is that at 1 o'clock, and the two hands are making basically 1/12 of full rotation together. That is 2 pi divided by 12. That makes it, so this is theta at the moment that we're discussing is going to be 2 pi divided by 12, which is pi over 6. So how do I take the derivative of this? Oh, remember, this one is just 8 times 8, 64. This one is just 16. This part is 2 times 4, that's minus 64 cosine theta. When I take the derivative, I get 2d dt, and these constants would go away, and I get equal to negative 64 and sine theta d theta dt. And I know d theta dt, and all I need to do is to find d, and d is going to be we have to plug in the values that I have in the law of cosine to find d, and we have all the values, and theta, we also have theta, and then we plug it back into the derivative and we compute it. And so in this side, and d over here is needed to be computed, sine of pi over 6 need to be computed, and we already found d theta dt. And that ends this question.